Hi everyone, and welcome to this new video of the series devoted to CytoPipeline, an R tool for building and visualizing pre-processing pipeline for flow cytometry data. In this video, we are going to continue our effort on visualization, and this time we are going to compare two runs of the same pipeline having different parameters run on the same data. So, in the previous video, we were left at a point where we were comparing the data set before and after a step, which was the remove debris step. And so we highlighted that this step was doing only partly well its job by removing the cluster around the origin, but still there were some of the undesirable events that were still present in the dataset after the run of the step. And so this problem, in fact, comes from the parameter that we selected in the method, because we selected k equals 3, so the number of clusters equals to 3, while here, in fact, we only have two well-defined clusters. So where does it come from that I selected originally this number of clusters equal to 3? Well, it was by looking at the data, meaning at the data prior to processing, and while looking at what was observed before all these steps, for example here. So prior to remove, after the remove margin, so basically prior to removing the doublets, there was still a more or less visible cluster here, so basically having now 3 different clusters. And it appears that by removing the doublets, this cluster suddenly disappears. So yes, as you can see. So most of the events that are present in this pseudo cluster have been removed by the remove doublets, the remove doublet step. So this means that this cluster is in fact made of mainly doublets, and after removing the doublets, we have this, so only 2 clusters. So when we enter the remove debris method, we want to highlight only 2 clusters, and if we ask the method to highlight 3 clusters, then it will start to find probably another cluster here, artificially set, and so when removing only the cluster corresponding to the origin, we still keeps the events that are undesirable at the top of the image here. So let's see what we get if we now change this parameter to 2. So saving again the JSON file, recreating now a new CytoPipeline object using the JSON file, using the same experiment name for now. Okay, and displaying the object, showing that now we have number of clusters equal 2. And let's try to display now the processing queue corresponding to this new CytoPipeline object. Then you have a warning message saying the CytoPipeline object is not consistent with the cache. And we flagged here an inconsistent preprocessing step number 4 for the sample file, this one, different in cache. And if you look now at the workflow graph, you can see that all the different steps are now highlighted in red. Meaning that, what does it mean? In fact, there are some results available on the disk, which I've run before, which appear to be not consistent in terms of the parameter set than what we have in the CytoPipeline object. So meaning that we cannot run this pipeline currently on the same experiment name. So what we will do is that we will change the experiment name of this CytoPipeline object to make it now no more HBVT demo, but HBVT_demo_2C for 2 clusters. Okay, so now we have an object with a different experiment name, and so if we relaunch this function, now we have a blank situation, so a blank sheet where we have a new workflow all orange, meaning that we have no results attached to the new experiment name, which is okay. And so now we can execute it the same way as before. Okay, it will take a few seconds to execute. Removing the doublets, debris, and so on for the first file. Starting PicoQC, and then doing the same stuff for the second file. Okay, let's wait a bit further. It's the end. Okay, it's done. If we display the situation on the right hand side, now everything is green. And so let's run again the visualization, but first let's have a look on the disk. On the disk, we have now two different experiment names here, and we have a new cache that has been created under HBVT demo 2C, new cache and new outputs. Meaning that now our visualization will be able to find those two experiments. And so let's launch the Shiny application. Now in the drop-down menu, we have HBVT demo and HBVT demo 2C. So let's have a look at what we have now in the new version of the pipeline run. So using two clusters in the remove debris step. And let's focus on this remove debris step to start with. Okay, let's also make sure that we have a fixed linear range for the scale, and let's also use all the sample events instead of subsampling. So let's wait a few seconds for the display to refresh. Okay, so now we have all events, and we can see that the step is now doing properly its job, because we have fitted two clusters and removed the one that is near the origin. So we don't have those undesirable events anymore. Quite good. So let's focus now on another use case of this, which is comparing two versions of the pipeline with different parameters. So let's now compare HBVT demo, so the original one, with HBVT demo 2C on the same sample file. And so we are now going to compare the same step but with two different pipelines, so with two different parameters. And you can see that indeed, as you could expect, if we compare the results of those steps, the same step but on the two different parameter set, we can see that there is indeed an issue on the left hand side, and this issue has been corrected on the right hand side, and we have the delta here. And that's it for this chapter that was devoted to comparing different pipelines with different parameters but using the same method. In the next video, we'll do something very similar, but now looking at pipelines that use different methods for QC, so quality control.